Hi everyone, welcome to Math 60. This is the video lecture for section 1.7. It is Foundations for Algebra by Hand, is what I'm calling it. Or Foundations for Symbolic Algebra, right? Because we talked about our four representations: symbolic, verbal, visual, and numbers, and how you can go from one to another, and how that's very useful when you're trying to understand or use mathematical ideas. And symbolic is working with numbers, symbols, equations, etc. So first piece of information is what are called identities. There are two that we're going to look at right now. There's an addition, subtraction, identity. An identity means a lot of things, but in this case does not change. So the addition, subtraction, identity is 0 added or subtracted to any number does not change the number. And that is our identity phrase right there. It does not change. 3 plus 0 is still 3. 7 minus 0 is still 7. 0 is called the additive identity. And one consequence of this is any number minus itself or subtracted from itself equals 0. This is going to give us some good tools for working with algebraic equations. 3 minus 3 is 0. Negative 7 minus negative 7 is 0. By the way, a minus a negative is adding a positive. So negative 7 plus 7 is 0. You could write that as any number plus its opposite. Any number plus its opposite equals 0. So that's the additive identity, or the addition and subtraction identity. And in arithmetic, we have addition, subtraction, multiplication, and division. So we also have a multiplication division identity. And that is any number multiplied or divided by the number 1 does not change. Three times 1 is 3. 7 divided by 1 is still 7. A consequence of this, that's again helpful, is any number except 0, 0 is a special case, but any number except 0 divided by itself equals 1. 3 divided by 3, that equals 1. Negative 7 divided by negative 7 equals 1. 1/2 divided by 1/2 equals 1. And we could rewrite this as any number, again, except 0, multiplied by its reciprocal equals 1. So the reciprocal, especially with fractions, is just flipping the fraction upside down. So 3/4 divided by 3/4, that's 1, but we could also write that as 3/4 multiplied by its reciprocal, which is what you get when you turn the fraction upside down. That's also 1. And whole numbers, their reciprocal, we get just by putting that number under 1. 2, we could write as 2 over 1, and so its reciprocal is 1 over 2. So those are our additive and multiplicative identities, which allow us to undo mathematical operations. And here's how we could use it. If I have 2x equals 18, any number divided by itself is 1. So if I divide the 2x by the 2, that's going to cancel and gives me x equals 18 over 2, which is 9. X can be written as 1x. And we usually, when we have run 1x, we just write it by itself. X equals 9. And if I have, as another example, x plus 3 equals 7, then to eliminate the 3, I can subtract 3 from itself, giving me x plus 0 equals 4. And a plus 0, we usually ignore it and just write x equals 4. All right, so that covers our identities and how we use them. Now let's talk about algebraic properties. There's a list of these. It's section 1.7.3 if you want to see that list in your textbook. But I'm just going to go through them one by one. The first is called the commutative property of multiplication. Commutative, how we say that word. And what it means as the written order doesn't matter when doing multiplication. 3 times 7, that's 21. But I can switch that order and say 7 times 3, which is also 21. Order doesn't matter. This is not the case for division. In division, written order does matter. If I take 10 divided by 2, that's 5. But if I do 2 divided by 10, that's 1/5. That's definitely not the same number. So written order matters for division. It does not matter for multiplication, and that is the commutative property. Also in multiplication, we have the associative property. Multiplication. And this property is the order, again, it's about order, but in this case, the order of operation doesn't matter for multiplication specifically. And in this case, it actually extends to division, but I want to focus on the multiplication. So 3 times 2 times 5, I can write that as 3 times 2 and then multiply by 5, which is 6 times 5, which is 30. But I could also write that 3 times 2 times 5 as 3 times the quantity 2 times 5, which is 3 times 10, which is also 30. It doesn't matter which multiplication I do first. That extends to division. I could do 4 times 12 over 2. So I could do the multiplication first and get 4 times 12 over 2, which is 48 over 2, which is 24. Or I could do 4 divided by 2 and then times 12, which is 2 times 12, which is 24. Or I could do 4 times 12 divided by 2, which is 4 times 6, which is 24. As long as the only operations are multiplication or division, it doesn't matter which ones you do first. As soon as you add addition, subtraction, etc., we have to start thinking about PEMDAS. But if it's just multiplication and division, it doesn't matter what you do first to get you to the same number. All right, so addition has the same two properties. We have the commutative property of addition. 3 plus 5 plus 7, I could see that as 3. Oh, sorry, that's not the one I wanted. That was the associative. 3 plus 7 equals 10, and also 7 plus 3 equals 10. So we can switch orders as long as we're adding numbers. Order does matter for subtraction. 3 minus 7 is -4, but if I switch and I do 7 minus 3, that's +4. They are not the same. So the commutative property, if all you have is addition, it doesn't matter which order you write things in. And there's an associative property of addition. This now, if I take 3 plus 7 plus 5, I could see that as 3 plus 7 first, and then add the 5, which is 10 plus 5, which is 15. Or I could do the 7 plus 5 first, which is 3 plus 12, which is also 15. And the associative property works also for subtraction. If I have 3 minus 8 plus 1, I could look that as 3 minus 8 first plus 1, which is -5 plus 1, which is -4. Or I could say it's 3 minus the quantity. I have to be a little more careful here. 3 minus 8 plus 1, I could do the minus 8 plus 1 first, which is -7. So that's 3 minus 7, which is -4. And it works either way. I have to be careful about my parentheses though, because if I am going to put parentheses, I have to put them around all of this and add an extra plus sign. All right, so what does this mean for us? Well, when collecting like terms, for example, like you have x squared minus 3x plus 2x squared minus 7, I can switch this order and make it x squared. Oh, that was supposed to be a squared. X squared minus 3x plus 2x squared minus 7. I can switch the order of my addition and bring the x squared terms together, which allows me to combine those like terms. That's the main way that these properties help us when working with variables, is just being able to switch things around and do things in different orders. Okay, so we have the commutative properties and the associative properties. There's one other very important property, and this one tends to be the tricky one, and it is called the distributive property. And distributive means multiplication across parentheses. When you have a term like 3 and you multiply it across something with parentheses, I'm gonna have to be, I have to be a little more careful. Multiplication across parentheses with addition or subtraction inside the parentheses. So here we have an addition inside the parentheses. Now, if I just wanted to do PEMDAS, I would do what's in the parentheses first, so that would be 3 times 7, which is 21. But if I wanted to distribute, then I would do 3 times 2 plus 5. That 3 multiplies by the 2. That 3 also multiplies by the 5. And we get 6, 3 times 2, plus 15, 3 times 5, which is also 21. When we're working with pure numbers, I'm going to pick PEMDAS every time. It's just easier. But it's more often that we're going to work with variables and numbers, and I cannot combine these using PEMDAS. 5 and x, or x and 5, are different terms. They're not like terms. So I have to distribute if I want to clear the parentheses, and I get 4x minus 4 times 5, which is 4x minus 20. Technically, this term here is actually plus 4 times negative 5. 4 times negative 5. And that's technically the right way to do it, which is 4x plus negative 20, which is 4x minus 20. But most of the time, when I see a positive number times something subtracted, I'm going to do 4 minus that number. This is one of the tricky places. Another one of the tricky places is, what if I have parentheses and it's negative outside the parentheses, and I want to clear those parentheses, so I want to get rid of them. Well, I have to see that as negative 1 times the quantity x plus 9, and I distribute that negative across both terms. Negative 1 times x plus negative 1 times 9, which is negative x minus 9. Negative of the quantity x plus 9 is negative x minus 9. And this right here is one of the most common mistakes, MCM, is forgetting that negative. Now let me show you another example. I'm going to try the autofocus real quick. Like we're out of focus. That was worse. Pause the video and fix this. Oh, there, it worked. That's better. Okay. All right, so another example with being careful with distribution. If I have minus 3 times the quantity negative 2x minus 8, I distribute the negative 3 across both. So it's minus 3 times negative 2x, and then plus minus 3 times the negative 8. That's one way to write it very carefully. This is probably the most challenging. I wouldn't call it a mistake like the other one. It's the challenging part. When you have a minus 3 times a minus 8, negative times a negative is going to make it a positive. So minus 3 times minus 2 is positive 6, and minus 3 times minus 8 is positive 24. So that positive sign makes sense. Another common challenge is a distributive property does not distribute across multiplication or division inside a parentheses. Let me give you an example. Let's do 2 times the quantity 3 times 4. If I just do PEMDAS, that's 2 times 12, which is 24. 2 times 3 times 4. All right, that's correct. If I try to distribute it, as in multiply by this one and multiply by this one, I'm going to have 2 times 3 times 2 times 4, but that's 6 times 8, which is 48, and that's wrong. Distributive property does not distribute across multiplication. Here's an example using variables. If I have 3 times 5x, this is going to be correct. I'm going to do it. You multiply the 3 by the 5. You don't multiply anything extra by the x. It's just 15x. Let's see why that's true. 3 times 5x says I have 5x plus 5x plus 5x, and now that's pretty clear. I have 15x's. Okay. The other thing to keep in mind with the distributive property is distribution should only be done across parentheses, not any other functions. At least not any other functions we're going to be studying in this class. And in fact, as we saw before, it should only be done when it's across addition or subtraction inside parentheses. And let me show you a couple examples. So here's a wrong. No, I'm going to do the right approach. Here's good mathematics order of operations. We're going to use the square root symbol, and we're going to do 2 times the square root of 9 plus 16. So we should treat the square root of 9 plus 16 kind of like a parentheses and do that first in PEMDAS. 9 plus 16 is 25. The square root of 25 is 5, and I get 10. So that's using PEMDAS. So that's correct. If instead I try to distribute and I say, oh, that would be 2 times the square root of 9. So this is distribute, and this is wrong. 2 times the square root of 9 plus 2 times the square root of 16. That's 2 times 3 plus 2 times 4, which is 6 plus 8, which is 14, and that is wrong. Distribution does not allow you to split up a square root. In particular, you cannot multiply and distribute. And even if I didn't have this multiplication, let's just look at the square root of 9 plus 16, which is the square root of 25, which is 5. This is correct. If I tried to split that into 2 square roots and added, it would give me 7, and this is wrong. So you cannot distribute or split up anything that's not inside of parentheses. If I have 2 times x plus 3 squared, and I want to get rid of the parentheses, I'm going to have to write the x plus 3 squared as x plus 3 times x plus 3. Now that I don't have a squared, I can distribute that 2 here and here, and I get 2x plus 6 times x plus 3. And now I can do a double distribution, or a FOIL, which we're going to come back to. So don't worry too much about your first look at this, but I'm going to distribute that 2x to both of these, and then I'm going to distribute that 6 to both of these. And I'm going to get 2x squared plus 6, plus 6x, 2x times 3, plus another 6x plus an 18. And now I can combine like terms and I get 2x squared plus 12x plus 18. But the point I want to make is that you cannot write, so this is correct, you cannot break this into 2x squared plus 2 times 3 squared. This is wrong. And it would also be wrong to write it as 2x plus 2 times 3 all squared. That is wrong. So you cannot distribute across anything but a basic parentheses. Here's a squared, so not basic. All right, that wraps up our video. Look out for the next video coming soon.